Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to another video lecture for the subject DLD. So the topic we are going to discuss today is the last topic of our first chapter, which was binary representation or binary systems. So the topic we are going to discuss will close the whole discussion of ours on binary systems. And without further delay, we start our topic for today. So you can see the name of the topic we are going to discuss today is binary logic. Binary logic basically deals with the variables and logic, or you can say the operations on those variables. So we are talking about binary. Those variables should be binary variables, and the operations we are going to perform on those variables, on those numbers, on that data is should be binary operation. It's quite simple. Now I have said that we are using binary variables. As you know that binary means two. So these variables, we can say variables can store two values. What are these variables look like? They can be anything in your alphabets like A, B, C, X, Y, and Z. But the thing which will differentiate them, which will put them in the category of binary variables, is the thing that they all of them should contains two elements, not both of the two elements, one of the either one of the two elements. And what are those elements? They are one and they are it's one and zero. So we know that binary variables are those variables which contains binary data. Binary data is of two types, 1 and 0, and the variables can either contain 1 or 0. They cannot have both of the values. So we will now take our discussion further. What are binary operations? As we have binary data, so we need binary operations on that data in order to manipulate binary operations. Okay, what kind of operations we are going to discuss, what kind of binary operations we are going to discuss, what is the result of this operation, and how these operations are carried out on the binary numbers, we will see in our next slide. There are basic three operations we have in binary, named as AND operation, OR operation, and NOT operation. These three operations, and now we will discuss what are these three operations, how they are carried out on binary numbers. A AND of two binary numbers is represented as, let's say we are representing two variables, binary variables A and B. So in the case of AND logic, A and B can be represented as A dot B or AB. So, and how it is done, how this operation is performed on number. Let's say we say that Z is equal to A dot B, or A and B, you can say. It means that Z will be 1 if and only if A is 1 and B is 1. If either of the A or B is 0, then Z, the value of Z will be equal to 0. Now we will discuss about this OR operation. We take the same example. We have two variables A and B. We represent it as A plus B, or A or B, or B. And let's say we have an equation, Z is equal to A or B. We can call it plus as OR. Okay. So how this equation will work, how OR gate, or you can say OR logic will work. OR logic says that Z is equal to 1 if A is 1, or if B is 1, or both of A and B is equal to 1. Now let's just differentiate or from and. In and we said that z will be equal to 1 if and only if a or b both are equal to 1 or both contains 1. And in the case of or gate or logic, we say that z should be equal to 1 if a is 1 or b is 1 or a and b both are 1. It means that we will discuss the gate later, and now we will briefly discuss this not gate here. It is just a complement. It is represented by, if we have a variable a, then the not of a will be represented by a prime, or you can say a bar or anything. Okay, a complement you can say. Now what, how this will work, how this gate will work? If a is equal to 0, then a prime it's not it will be equal to 1. If a is equal to 1, it's not will be equal to 0, vice versa. It's opposite. A and a prime is the not. This is a and this is a prime. Now we have a look, we will have a look on the table. Here you can see that this is AND gate. Now this table will tell us how AND gate works. We have x is equal to 0, y is equal to 0. So the answer which we can call z or x dot y, I told you that we can represent AND gate with x dot y or xy. If x is 0, y is 0, then xy is equal to 0. If x is 0, y is 1, still we have answer 0. If x is 1 and y is 0, still we have answer 0. Sorry, answer is 0 in all of these cases. The answer will be 1 if and only if x and y is equal to 1. We have discussed it in the previous slide. Now we will see about this OR gate. We have been told in the previous slide that the output of an OR gate will be equal to 1 if x is 1 here, if y is 1 in this input, or if x and y both are 1. Okay, the output will be 1, otherwise the output will be 0. This is the NOT gate. Okay. You can see now. This is the NOT gate. I told you if x is 0, x naught, x prime or x complement is equal to 1. If x is 1, then x naught, x prime or x complement is equal to 0. Here in this slide, there are two examples of AND. Please. Of AND and OR gate. These are just a simple electrical signal. Here it is a light bulb. Here are two switches A and B. A is closed, it means A is equal to 1, and A is open represents A is equal to 0. Now let us make a truth table here for AND gate. If A is open and B is open, mean the circuit is open if A is equal to 0, B is equal to 0, our light bulb will not light. Okay, it will give us output 0. If A is 1, what will happen? The current will come here from the battery. This is the battery. A is closed, A is 1, the current will go. Now at this point B is open, the switch of B is open, so B is 0. We have no light, we have no current in the light bulb right now. Same, A is equal to 1, B is equal to 0, we have answer is equal to 0. If B is equal to 1, now let's say if current flows from here, the bulb will not get enlightened till the circuit is complete. As B is closed, in this case, we are assuming B is 1. The current will come from here, pass through B and stops here because A is open. If we write it as in binary, A is 0, B is 1, our output will be 0 because our bulb is not lighting up due to the incomplete circuit. Now, in the last case, if both A and B are 1, if you can see in the diagram, if both switches are closed, the current will follow and return to its other pole of the battery or the other terminal, hence resulting in a light enlightenment of a light bulb, giving us output is equal to 1. This is AND gate. Okay. Now same electrical signal, it is showing the working of OR gate. Let's say if A is open, A is 0 or B is 0. What happen? A is 0, B is 0, bulb will not will not lighting up, so answer is 0 here. If A is 1 and B is 0, what will happen? If A is closed, the current will come from here, adopts this path, goes through the bulb and return back to the battery, hence enabling our circuit. Our answer will get 1 because we have light coming from the bulb here. If A is open, okay, and B is closed, what will happen? Our current comes from this terminal, goes through B, goes through the electric bulb and turns back to the battery, hence giving our signal 1 at the output. We have said that A is equal to 0, B is equal to 1, answer is 1. And what happens if both A and B are 1? We have no issues in this case. The current can flow from both of them, goes through the bulb and return back, hence giving us an output of 1. We can say A is 1, B is 1, so output is 1. Simple. These two electrical circuits, simple circuits, shows us how the working of AND gate and OR gate occurs. Now we will discuss different types of these gates, AND gates and OR gates. Here you can see it is two input AND gates. The terminology two input AND gate means the gate has two inputs, X and Y basically. And Z is basically the AND of X and Y. Here the AND gate is represented by this symbol. The OR gate is represented by this type of symbol. Two input OR gate, it takes two inputs, compute its OR and gives us the output. And the NOT gate is represented by this triangle at the and the bubble in the front. So if X is 1, X prime will be 0, X is 0, X prime will be 1. Here you can see three input AND gates. AND gate, it will AND both the three inputs and then gives us the answer. The procedure of AND will be same. I will explain a bit here. F will be 1 if and only if A, B and C, all of these three inputs are 1. Otherwise, if any one of these three inputs is 0, we have no no signal coming through the output. Okay. Similarly here, 4 input AND gates, it will it will OR the input, or it will OR the all the 4 inputs and gives us the answer. Now a little difference I will tell you about binary logic and binary arithmetic. In binary arithmetic, we know that 1 plus 1 is equal to 1, 0, which represents 2. If we represent this 1, 0 in decimal form, it will gives us answer in decimal form, which is equal to 2. But in the binary logic, if A is equal to 1, and I hope you recall this symbols I have told, this is the symbol of OR. Okay, 1 or 1 is equal to 1. This is a little bit difference between binary logic and binary arithmetic. Here actually we are not actually adding both of these values. These are just signals here which are telling us that what output our gate should emit. So this was a little difference between binary logic and binary arithmetic. So it's all for now. I hope you like the video. If you like, do subscribe my channel, hit the like button and press the bell icon so you never miss any video from the lamp of knowledge. I'll say goodbye to you for now. Allah Hafiz.